Hi there, how's it going? This is Brain Training, a place where I train my English by explaining LeetCode solutions. And for today's session, we got these 912 sorting an array. And this question is asking us to arrange an integer input array in ascending order, which means arrange the elements within the input array so that they appear from the smallest to the largest. And we also have a constraint here in the problem that asks us to come up with a solution that runs in n log n time complexity. But we're not going to pay attention to this constraint right now because for this first attempt, we're going to solve this by brute force. In other words, we're going to use bubble sort, the easiest sorting algorithm to implement, but also the slower of them all. And now, without further ado, let's dive into how the bubble sort works. Bubble sort. So here we have the example that we're going to use in this walkthrough. A bubble sort is a pretty simple algorithm. We're going to iterate over the entire array multiple times. We're going to have multiple passes throughout the entire array. In each pass, we're going to place the largest element in the last position. That's what we're going to do. That's only what we do. And then at the second pass, we're going to place the second largest element in the second last position. That's what we do. And we're going to repeat this until the entire array is sorted. The first thing we do is placing 2 pointers in the beginning of the array. We're going to use I and I plus 1 and compare the two elements. That's how the algorithm works. Compared to the two elements next to each other, or we can say also adjacent elements. Adjacent elements, but the two elements next to each other, and compare if the first element's greater than the second element. That we do that because we want to move the largest element to the end of the array. So we're going to do this by just comparing the two pairs of elements. So the first element is greater than the second one. It is, so we're going to swap them, and then we keep going with the next iteration, the next comparison. So now we're going to compare 5 and 3. 5 is greater than 3. It is, so swap them. And then to the next iteration, we're going to compare 5 and 1. Is 5 greater than 1? It is, so swap them. That's it for the first pass. So we're going to repeat this until all the elements are sorted. Again, for the second pass, we start from the beginning, obviously, and we compare the two elements, the two adjacent elements. Still greater than 3? It is not. So we do nothing. Just move to the next iteration. 3 greater than 1? It is. So we're going to swap them. And here is where the algorithm gets interesting, because we don't need to go over the next position anymore, because we already know that the end of the array is already sorted. And we can stop here and go to the next pass. And for the third and last pass, we just need to compare the last two pairs, 2 and 1. So is 2 greater than 1? It is, so swap them. We don't need to go any further because we already know that the remaining is already sorted. That's it for the entire array, for this entire array. That's how bubble sort works. Hello, Paulo from the future. I tried to make jokes, but I can't. I cannot do it. Hi, Paulo from the future here. Let's keep on going with this code. I had to postpone this code solution for a while, but here I am. Let's get this over with. So now it's time to code it up, the solution, to see how all this algorithm translate to code. So we're going to start with the outer loop first. This is our outer loop in Kotlin. First thing you have to notice is that now we have this -1, but don't mistake this with the Java -1, length -1, because Java length -1 is equivalent to this, because Kotlin use ranges. What this means is we want to iterate from 0 up into size -1. That's what this for loop is saying. This is a range not included, which means that the last index is not included in this for loop. So we use this extra -1 over here because we don't need to go over the fourth pass in this case for this example. Because we have 4 elements in the array, but we don't need 4 passes because in the third pass we already solved the remaining items, the 2 remaining items. The last pass will be redundant because we already solved the entire array in the third pass. So this is why we do this, to avoid redundancy in our code. Let's go to the inner loop. So for the inner loop, we also have this -1, extra -1, but this time is just to avoid going out of bound, because here, as you can see, in the first pass, we are comparing 2 elements, I and I plus 1. If we go any further, we reach this scenario over here. That's not good because this is out of bound, and that's will throw an exception. So this is why we do the first -1 there. And also the neat little trick that makes this inner loop get smaller in each pass is this -j. So in each pass of the outer loop, this inner loop will decrease by 1 in each pass. This is what we see here. The first pass we go from here to here. Second pass we just iterate over this portion, and the last pass we iterate over this session over here. So that's what this -1 does. It's decreasing our inner loop 1 by 1 in each pass. Because we know that the remaining items, the items on the right, they're already sorted. So we can just ignore them. And finally, we have the comparison and the swap. If I is greater than I plus 1, we're going to swap. And here we have the very standard technique to swap 2 elements in the array, just using a temp variable to hold one of the values so we don't lose it. And then we do the swap, the exchange between numbers, between positions. And then we are good to return the entire array. And that's what we do. That's the code. Nothing fancy, easy to understand, easy to memorize. Because you have to just memorize this type of algorithm if someone asks you how to implement it, but it's nothing fancy. Very clean, very clean. Let's give this a try. First, let's run the basic test cases, and we pass. And now let's give this a true test. Go submit this question. Let's see what we got. Time limit exceeded. Yeah, we didn't succeed in finish this question with this implementation as expected, because our algorithm is a n square algorithm. Time complexity of this algorithm is n square. Oh, n square. Because of those 4 loops, we keep iterating over the entire array multiple times and making multiple comparisons and swaps. So that's what happened here. And for space complexity, we have the nice constant time for space because we don't need any extra space. So that's good for this algorithm. But as you can see here, we were not able to conclude this algorithm, finish this successfully, because look, the size of this array is huge, gigantic. That's not a good algorithm for large data sets. That's why everybody hates bubble sort. Not hates, but in bubble sort's not applicable to large list of elements. But it's a really good algorithm to learn nonetheless, because as you can see, it's really easy to implement and pretty straightforward to understand. So I give this a 7 out of 10 because I really enjoy this algorithm. The implementation, I find smart, simple. I like it. Just a little tip that could improve this algorithm. This is for the cases where we already have an array that is already sorted. You can use a flag to skip the inner loop and just return the entire array. So you don't need to keep iterating over an entire array that is already sorted. I start here before we jump into the inner loop. And in case we swap, numbers, this flag will be true. That means that we have still have a array that is not an unordered array. And down here, after the for loop, the inner for loop, we'll just check whether or not we swapped elements. In Kotlin, by the way, we can use this not because we are negating. So this will, if this is false, the negation will be true. So we can return input array or the output array now in this case. But we also can do like this exclamation sign. And we also can do like this to make even more explicit. You choose your poison. Kotlin gives you a lot of ways to write the same thing. But I guess idiomatic, the recommendation is to be like this. Okay, return the output array because we already know this is sorted. Let's see if we got some improvement out of this. Time exceeded again, and we reached the same test cases. 16 test cases passed. No improvement whatsoever. But this is a way to a little improvement in this algorithm. So that's it for the bubble sort. This will be our first attempt to solve this LeetCode problem. I will try again with different algorithms, but that's it for now. I hope you enjoy it. See you in the next video. Bye-bye.